third part of simultaneous equations. First of all, we looked at the graphical model where we looked at the point of intersection is one way to solve it. Another one is substitution. And finally, we're looking at elimination, okay? The elimination method. So what we have to do is eliminate x or y by adding or subtracting equations at the same time. And you should have everything in terms of x or everything in terms of y, but not both, okay? And then this substitute thing is what we did in the last lesson, so I'll do it with the examples again. All right, so I'll probably move ahead, so make sure you rewind, pause it. Title, learning goal, success criteria is in your book. Okay, let's have a look at this. So I'm going to label it 1 and label it 2. Okay, so just to give a distinction. And what I am going to do is I'm going to eliminate one of the two. Now, essentially what I'm doing is I'm going to add downwards like this. Okay? So I'm going to add downwards like that. So I need to explain what I'm doing, so I'm going to go 1 plus 2. And the reason why I'm adding, you'll see when I do the example, is that, let's do it first. X plus x, well, that's 2x. Now, the reason why I'm adding is here, plus 2y minus 2y, well, that gives us 0. That's awesome. We've eliminated y, and now we've got everything in terms of x. And so finally I go 7 plus 1, and I get my answer as 8. So therefore I'm left with 2x equals 8. I can divide both sides by 2. Therefore x equals 4. Now I need to sub 4 into one of the equations. So I'm going to go sub x equals 4 into, I don't know, 1. Okay, so I'm going to substitute it into one of these formulas. So I'm going to substitute it into there. So I get 4 plus, now I have to write the rest of it out, 2y equals 7. And now I've got to solve for y. So I'm going to minus 4 here, minus 4 there. So I'm left with 2y equals 7 minus 4 is 3. And then I'm going to divide by 2, divide by 2. So therefore y equals 3 on 2 or 1.5. It's the same thing. Okay? So that's that. So, therefore, we have a coordinate of 4 and 3 on 2. Okay? Because remember that this is x, so that's x, and this is y, so that's y. Okay? All right, I'm going to do the same thing. I'm going to rub everything out, so please pause to write this down. And now I'm going to get started on example number 2. Okay, so I decided to add in the last one, and I've got to see if I need to add for this one as well. So first of all, I'm going to label it. Now I'm going to choose to take one away from the other, because if I go 3x plus 3x, it's going to give me 6x. So I can't add. But if I go 3x minus 3x, I get 0x. So I'm going to do that. So I'm going to go 1, take away the second equation. So let's do that. 3x minus 3x is just 0x, so it's just 0. And then I'm going to go 5. Now this is where you have to be careful. Minus 3y. Now I'm not sure if you heard me, but there's 2 minuses. And in maths, 2 minuses mean a plus. So this is essentially what I'm doing. 5y minus 3y. And so those 2 y's will give me a plus. So 2 minuses give me a plus, sorry. So I'll get plus 8y equals, and then let's look at the last bit. 10 minus 2, that's just 8. So I'm left with 8y equals 8. So therefore, if I divide both sides by 8, I'm left with, therefore, y equals 8. So now I've got to sub the y into one of the values, so I'm just going to sub it into 1. Sub y equals 8 into 1. And what I have is I'm going to sub it into there, so I've got to put brackets around that. So I'm going to go 3x plus 5 times 8 equals 10. And now I have to solve for x. 5 times 8 is 40, so I'm going to put 40 there. That equals 10, and it's just going to be 3x plus 40. Now I've just got to solve it. So minus 40 minus 40. So I'm left with 3x equals negative 30, looks like. And now I'm going to divide both sides by 3 to get rid of that there. So therefore, x equals negative 10. So if I write it as a coordinate, I get minus 10 and 8. And that's because x is minus 10, so that's our first coordinate, and y equals 8, and that's our second coordinate. Alright, so that's simultaneous equations using elimination. Peace out.